Welcome to this lesson on Amazon Web Services subnets. In this video, we'll explore how subnets work within a virtual private cloud, or VPC, and learn about the key differences between public and private subnets. Subnets are fundamental building blocks for organizing and securing your cloud infrastructure on AWS. A subnet is a logical subdivision of your VPC's IP address range. Think of it as dividing your network into smaller, more manageable sections. Each subnet must exist entirely within a single availability zone and cannot span across multiple zones. Resources placed in different subnets can still communicate with each other within the VPC, but subnets give you powerful control over network segmentation and organization. This allows you to group similar resources together and apply specific security and routing policies to each group. Subnets use CIDR blocks to define their IP address ranges. CIDR stands for classless interdomain routing. For example, a VPC might have a CIDR block of 10.0.0.0/16, which provides 65,536 IP addresses. Within that VPC, you can create smaller subnets, such as 10.0.1.0/24, which contains 256 IP addresses. However, only 251 of those addresses are actually usable, because AWS automatically reserves 5 IP addresses in each subnet for essential networking purposes like the network address, VPC router, DNS server, and broadcast address. A public subnet is designed to allow resources direct access to the internet. What makes a subnet public is that its route table contains a route pointing to an internet gateway. Resources launched in public subnets can be assigned public IP addresses, making them directly accessible from the internet. Public subnets are commonly used for resources that need to serve content or accept connections from the public internet, such as web servers, load balancers, and bastion hosts. The Internet Gateway acts as a bridge between your VPC and the public internet. In contrast, a private subnet provides enhanced security by isolating resources from direct internet access. A private subnet does not have a route to an internet gateway in its route table. Resources in private subnets use only private IP addresses and cannot be directly reached from the internet. However, if these resources need to access the internet for tasks like downloading updates or making API calls, they can do so through a NAT Gateway, which stands for Network Address Translation Gateway. This provides outbound internet access while keeping the resources protected from inbound internet traffic. Let's compare the key differences between public and private subnets. Public subnets have a route to an internet gateway, use public IP addresses, and are typically used for web servers and load balancers that need to be exposed to the internet. Private subnets, on the other hand, have no internet gateway route, use only private IP addresses, and are ideal for databases and application servers that should remain protected from direct internet access. This multi-tier architecture approach, combining both public and private subnets, is a best practice for building secure and scalable cloud applications. Route tables are the key to controlling traffic flow in your subnets. Each subnet is associated with a route table that determines where network traffic is directed. In a public subnet's route table, you'll see 2 routes, one for local VPC traffic, which keeps communication within the VPC, and another route for 0.0.0.0/0, which represents all other traffic and points to an internet gateway with an ID like IGW-XXXXX. For a private subnet, the local route remains the same, but instead of pointing to an internet gateway, the 0.0.0.0/0 route points to a NAT gateway with an ID like NAT-XXXXX. This configuration ensures proper traffic routing while maintaining security boundaries. Understanding when to use each subnet type is crucial for designing effective cloud architectures. Public subnets are perfect for web servers that serve content to users, load balancers that distribute incoming traffic, and bastion hosts that provide secure administrative access. Private subnets excel at hosting databases that store sensitive information, application servers that process business logic, and backend services that don't need public exposure. The most powerful approach is combining both types in a multi-tier architecture, where public-facing components sit in public subnets and sensitive resources remain protected in private subnets. This layered approach provides both accessibility and security, giving you the best of both worlds for building robust cloud applications.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.